Good morning, friends. Today we are going to discuss about the L2VPN configuration of basic troubleshooting on IOSXR. Let's start first with the Ethernet flow point or attachment circuit configuration. So Ethernet flow point is nothing but your sub interface where you are configuring the L2 transport, which will become as a layer 2 interface. So under that layer 2 interface, we have encapsulation option, where under that encapsulation option, we have many options to configure, like default. Under default, it will match the all unmatched traffic. Means suppose you have many sub interfaces configured. So suppose this is the 0 0 0 4.1 4.2 4.3. Here you have matched with the VLAN 100, VLAN 200, and only two VLANs are configured. So VLAN 100 will match with this sub interface, VLAN 200 will match with this interface, and rest traffic will match with this default interface. So next is .1q. So encapsulation .1q, where we can define the VLAN tag for that particular sub interface. Next is untag. Untag means you can match the untag packet like your CDP packet. So under encapsulation .1q, we have option to define the single VLAN. We can define the VLAN range. We can define 9 entries here by using commas, 9, 10, 11. So and we can define the total 9 entries here. So we can define any VLAN as well. If I defined any under this one, so it will match all VLANs. So priority tag is generally we are using for VLAN ID tag 0. So next is under that encapsulation .1q100. Then under that encapsulation .1q100 we have many options. We can define the comma, means as earlier we mentioned that we can define the 9 entries. So you can define the 9 commas like 100, 200, 300, like that 9 entries you can define here, because it is TCAM limitation on ASR 9K. Second VLAN tag .1q. So suppose if you have defined first one is 100 and then second you can define 200, like we can say that is QNQ. So if any if any frame hits this interface, then most specific match will win here. Like for IPv4, we can say that 1.1.1.1/32 is most specific match over 1.1.1.0/34 is most specific match over the 0.0.0.0. The same principle applies here as well. So we will see it. So encapsulation .1q100. So we will see that will match any number of VLAN header as long as outer VLAN tag is 100. So we can see that outer VLAN tag is 100. This is Ethernet frame with VLAN 100. It will match here for this sub interface. If frame comes with 100, second VLAN 200, it will match here. If frame comes with 100, 200, 300, it will match here. As long as this first VLAN interface is 100, it will match that particular frame. Second is encapsulation .1q100. Second, any. So second VLAN tag could be any. So here in this case, these two will match here. So this first will not match here because we have defined the second any. So second VLAN tag should be there. So other could be like 100, 300, 400, like that we can match that packet here. Encapsulation .1q100, second VLAN is 200. So here this will match and this will match, but this will not match here because first and second VLAN should be 100 and 200. So here we can say that outer VLAN should be 100 and inner VLAN is 200. Encapsulation dot 1q 100 second 200 exact. So here suppose if frame comes with 100, 200, 300, it will not match this sub interface because here 3 VLAN tags are there. Only frame comes with 100 and 200 will have exact match. Means if frame comes with only 100 and 200, it will have exact match for this sub interface. But in earlier scenario, we can compare this scenario and this scenario. We can see that without exact, it can match up to 3-4 whatever VLAN tag options are there, it can match up to that one. But if it is exact option, only first and second VLAN, if we have defined there, it will match up to that 2 specific entries with that exact VLAN tag. Next is VLAN manipulation. We can see that we can manipulate the VLAN on EXR devices like ASR9K. We can remove that particular tag, we can push one more tag, or we can translate that particular tags, VLAN tags. So here this is the sample configuration. So this is the attachment circuit or EFP configuration. So we could see here we have configured encapsulation.1q100. So this is that interface, this is P box. If frame comes with VLAN tag 100, so using this VLAN manipulation, rewrite ingress tag pop1. So what we are going to do, when the packet when P router is sending the packet over pseudo wire, it will remove the VLAN 100 and it will just send the Ethernet frame without that VLAN tag 100. This is means we are popping that particular VLAN. If push is there, it will add that whatever push configuration you have defined, it will add that particular VLAN on the pseudo wire and it will send it over the pseudo wire. This symmetry. So when frames when P receive the frame over the pseudo wire, it will add that particular VLAN tag 100 and it will send it back to C router. So here in the second option, in this second operation, we are doing the reverse operation, we are adding back. But in the first option, we are removing that 100. So that's the reason this symmetry works. So next is we can under the pop option, we have option to remove tag 1, we have option to remove tag 2 tags. So rewrite ingress tag translate. So here we can translate the tag. Suppose if I am receiving the frame with 100 on particular sub interface and I want to send it with VLAN 200. So I can define here translation. So here it will work one-to-one translation. So here 100 I am replacing with the 200, and we have other option, replace the tag 1 with the tag 2, replace the tag 2 with tag 1, replace both tag 2 with both 2 tags. So generally this pop, push and translate scenario is useful when we are using the inter-VLAN communication. Next is local switching. Under the local switching, it's just act as the switch where frame received on one interface will switch over the other interface. This is the point to point. So no MAC address table will be maintained on P because router knows that if frame receives on interface, I need to switch it on other interface. Whatever frame may be there, it could be unicast, multicast or broadcast. So this is we called as inline services. So frame ingress on one EFP are switched to other and vice versa. So as we discussed, there will not be any MAC learning performed because it is point to point, and router knows that if a frame received on one interface, I need to switch it on another interface. So we can configure the VLAN manipulation, right? We earlier discussed rewrite ingress tag. Using that command, we can manipulate the VLAN. So we will see the configuration here. So this is the same configuration which we discussed earlier. So this is the layer to transport sub interface EFP. So here we have defined the .1q tag 100. So here we are doing the pop one option symmetry. The same configuration will be applied on other end, but to simulate the VLAN scenario, I have defined here .1q tag 200 and pop one symmetry. So here frame comes with VLAN 100. I'll pop it out and I'll add VLAN 200 here. And in reverse direction, if frame comes with VLAN 200, I'll pop it out and I'll add VLAN 100 so that inter-VLAN communication will be through. So this is the L2VPN configuration. Under cross connect group, I have defined it name as local switching. This is point to point. I have defined the P2 P1 name. So I have called these two interfaces under the L2VPN. So these two interfaces are attachment circuit interface, or we can say that Ethernet flow points. So if we are trying to add third interface here, it will throw an commit error because router knows that this is the cross connect is point to point, and it will not going to add the third interface. So if you have requirement where you need to define the multiple interfaces under that particular bridge domain, so you need to configure the bridge domain where you can configure any n number of interfaces under that one. So next we will see the troubleshooting for that point to point local switching. So we can see here, this is the L2VPN name. It's showing status is up. This is the segment 1 interface attachment circuit. It is showing up. Segment 2 attachment circuit, it is showing up and running fine. So we could see that local switching status and interface status are up and fine. So for troubleshooting purpose, we have just pinged the IP address with the count 100 and timeout 0 from CE to C. We can see that packets are going through. So we will see the counters. So if we see that show cross connect group local switching detail, so we will see that status is up, local switching status is up, and we could see that VLAN configuration is 100, and here we have received the packet 100 from the CE. So we have pinged from here with packet 100. So we have received the 100 packet and sent is 103. Here it is sending back to CE, it is 103. This 3 packet extra could be control packet. So this is, we don't see any drops. Illegal VLAN drop is 0. Illegal VLANs means if I receive frame with VLAN tag 200 on this .1q with the .1q 100, then this illegal VLAN counter will increase. So on this other interface, we could see that this VLAN is 200, so only one VLAN is there, and receive is 103. Receive means from CE we have received 103 and send is 100. We are sending back, sending 100 packet to customer edge device. So we could see that end-to-end communication is working fine. So we could see that on PE on other interface we are getting 100 packet and we are forwarding 100 towards the CE, and ICMP reply packet we are getting 103 on PE and we are sending 103 packet towards the originating CE. So we could see that end-to-end communication is working fine here. So next we will check the forwarding status of that particular line card for that interface. So we could see that hardware, and we are checking at ingress direction for that particular line card. So cross connect is up. So we could see that we have received 100 and sent 340. So 340 could be control packets. So we don't see any drops here. And this is segment 2, means other interface. Status is showing bound. And this is the UIDB programming for that particular interface on ingress direction. So this is UIDB program. So if you received the VLAN 200 on .1q interface 100, if you see the ingress programming for this particular inbound interface, we can see that UIDB programming. So if you receive the illegal VLAN frame on this ERP, so suppose if you have received the VLAN 200 on .1q interface 100, so you will see that this pass drop in UIDB TCAM miss counter will increase on ENP. So you can see that on ENP5 you will say that this counter will increase. So you can figure out that okay, I am receiving the illegal VLAN frame on this particular interface. So under the programming you can see the VLAN 100 and VLAN 2 is 0. We don't have any VLAN 2. This is layer 2 ACL. If we have configured any, this is layer 3 LCL, and this is COS configuration. So we can check the UIDB programming for this interface. Same thing we will verify for the egress direction for the same interface. So here it is same, received 100, sent 350. So status for the remote interface status is bound, and this is the egress programming for that particular interface. So we can see that UIDB programming, layer 2 ACL, layer 3 ACL, VLANs, and if any COS configuration. So we can verify all this for troubleshooting purpose. In earlier commands, we see that we could see the received and sent counters, but still, if we want to match the counter, we can either apply the layer 3 we can apply either layer 3 ACL or layer 2 ACL to verify the match. So here I am pinging count with 100, rapid count is 0. So I have applied the layer 3 ACL on Ethernet flow point here. So we could see that my destination is 10112, source packet, source of that packet is 10110. So it is hitting on ingress direction. So I could see that 100 matches are there. On egress direction, I could see that packet is leaving 100, means end-to-end communication is through. Same thing we can verify using the layer 2 ACL. So you can see here these are customer ages MAC address. So this ACL, layer 2 ACL I have applied on ingress and egress both direction. So we can see the counter. This is ACL name. So hardware ingress location. So here you can see that I could see that 100 packet match here, and again on egress direction I could see that 100 packets are leaving towards the CE. So we could see that packets are hitting correctly using this layer 2 or layer 3 ACL. So this is about the local switching. So next we will go to virtual private wire service or Ethernet over MPLS or Atom. So here we will form the pseudo wire between the PE routers. So we could see that once we configure this pseudo wire, so pseudo wire will be before that targeted session will be formed, targeted LDP, over which your pseudo wire VLAN pseudo wire, or you can say L2VPN label will be exchanged. Once targeted session is up, your pseudo wire will come up fine. So once pseudo wire is up, then you can your end-to-end traffic will be working fine. So here we could see that configuration for that Ethernet flow point. So it is the same as discussed earlier. So this is the L2VPN configuration for PE1. So here we could see that cross connect group L2VPN test, then P2P I have defined point to point. So this is the attachment circuit, and this is neighbor IP address. This one is 19.1.1.1. This is pseudo-wire ID. This pseudo-wire ID should be the same on both sides, then only pseudo-wire will come up fine. So here we can see the L2VPN configuration on other inbox. So we could see L2VPN test. This is attachment interface, attachment circuit, and this is the remote IP address, and we could see here pseudo wire ID is 20. So here both should match, then only attachment targeted LDP session will come up and attachment circuit will form over that one. So we could see that attachment targeted LDP session between both session will be up, and in turn pseudo wire will be up. So next we will verify the MPLS connectivity between core. So we can see that trace route MPLS, so it's working fine, and I have verified the pseudo wire status as well, so I'm able to ping it. So pseudo wire status is also up and it's working fine. So we can see the L2VPN status. So we could see that L2VPN test point to point is up and running fine. So segment 1 attachment circuit, it's up and running fine. So this is pseudo wire segment 2, it's pseudo wire 20, it's up and running fine. So we can verify that my pseudo wire is up and running fine. So next we can verify the counters. So here we could see that L2VPN test status is up, and here VLAN status. So here we can verify the received and sent. So currently I am not sending any traffic over it, so these counters are 0. So again we can verify the illegal VLAN counter. So here we can see that if I am receiving any packet from the CE, I am going to switch it over the pseudo wire. So here this is remote IP address for pseudo wire ID is 20, state is up, and pseudo wire type is Ethernet. We have two type of Ethernet pseudo wire type. One is Ethernet and one is VLAN. So for Ethernet, VLAN tagging is not mandatory, but for VLAN tagging should be mandatory. And in case if VLAN is not there, then 0 will be added and frame will be the same. VLAN 0 will be added and frame will be the same. Frame will be sent over the pseudo wire. So here we could see that labels. This is local label and this is remote label received from other end. So we can see the attachment circuit status, and we could see that EMTU. If there is EMTU mismatch between both attachment circuits, then your pseudo wire will not come up fine. And again one more problem is there. If you have attachment circuit between ASR9K and other device, suppose 7600, so problem is that 7600 or other devices will consider MTU as IP plus data, so this will be considered as EMTU, but on ASR9K it will consider Ethernet, IP frame and data, so this complete will be MTU. So in case if you defining MTU 2000 here, so here you need to add the Ethernet header as well. So you need to define the 2014 EMTU here, else your pseudo wire will not come up. So here we can see that the statistics, we can see that packet received and sent on pseudo wire. So for debugging purpose, I have created one scenario where I am pinging from pinging 10.1.2 source 10.1.1, and I am not able to go through because some problem is there in the network, so we can verify that one. So here is show L2VPN forwarding interface, attachment circuit name, detail, location. I am checking the counters, so I could see that interface status is up and running fine. So I could see that I have received the 100 packets. So CE devices, CE1, PE1, and this is pseudo wire. So we could see that I have received the packet 100 from the CE, but sent is 0. So we could see that P router is not sending any packet. So this could be the issue with PE1, or this could be issue with the remote PE. So we need to figure out that one. And on pseudo wire status, we could see that this is remote end device, pseudo wire is 20. So we could see that we received packet 0 but send is 100. So again on pseudo wire we are sending the 100 packet but receive is 0. So we have confirmed that there is no issue with the PE1. So we need to figure out the remote PE. Is there any issue, or is that router is dropping any pseudo layer 2 VPN packet or not? So on these devices we can again verify using either layer 2 ACL or layer 3 ACL. So we can see on ingress direction 100 matches are there, means we are getting the ICMP request, but a reply is not going through that device. So we can see that 0 matches are there. So again same thing we can verify using the layer 2 ACL. So here we can see that incoming is 100 towards that P, but outgoing towards that C is 0. So we will verify on remote end device now. So we can see that show L2VPN and that interface status. So this is that attachment circuit, and we can see that, so this is the P2 and this is CE2. So we can say this is the attachment circuit status. So we can see that router is sending 100 packet towards the CE2, but it's receiving 0 here. So here receive is 0, but sending on that attachment circuit is 100. So we can check the pseudo wire status. So this is the remote 19.1.1.1. So on pseudo wire we received the 100, but sending 0 packet. So we have confirmed that we are sending the packet towards the CE2, but we are not getting any packet from CE2. So we have confirmed that there is a issue with CE2. So for debugging purpose, I have applied the ACL here, which is blocking the ICMP packet. So this way we can troubleshoot the packet end-to-end packet. So next is pseudo wire stitching or multi-segment. So this generally comes when there are two ISP, suppose ISP1 and ISP2, and their customer wants layer end-to-end layer 2 VPN connectivity. So in that case we can use this stitching. So here configuration is almost same. So this is the attachment circuit configuration. We can configure same as like mentioned earlier. So here it is L2VPN configuration, cross connect group, Cisco, P2P is P2, PE1 to P2, and interface, this is attachment circuit interface, and this is neighbor. So I have given pseudo wire ID is 12. On PE2 I have defined the same configuration, neighbor is 10.1.1, pseudo wire ID is 12. So once we are done with this configuration, pseudo wire will be up between PE2 and PE1, that is pseudo wire 12. So for next pseudo wire between PE2 and PE3, on PE3 we have configured L2VPN cross connect group Cisco, then P2P, PE3 to PE2. Yeah, this is attachment circuit. This is the remote PIP address 10.0.0.2, pseudo wire ID is 23. So same pseudo wire ID I should mention here, pseudo wire ID 23, neighbor 10.0.0.3. So once we are done with this configuration, then pseudo wire 23 should be up between this interface. Once pseudo wire, both pseudo wires are up, then if P2 received packet on pseudo wire from P1 and switches the packet to P3 over the pseudo wire 23. So end-to-end communication will work fine.